Hi, thanks for joining me again for what I've been talking about so far is code auditing. Um, this week, actually the next few chapters in the book were on Windows, and I read the first chapter and I just didn't find it very compelling in terms of actual code problems that you would actually see when you're auditing. So I decided to skip it. There's a lot of problems in code dealing with cryptography, as you already know. I saw this video and I thought it was kind of interesting. The team leader for a project, actually the company is Matasano, but the team leader was trying to train the younger engineers or programmers to do this auditing. And so he created a bunch of exercises for them to do, and usually, well, there was 8 problems in each set, and there were 6 or 7 sets. I think he's actually working on the 8th set now. But the problems were, they were derived from problems that they had seen while they were doing the code auditing. And so what happened was he created the exercises, and then he thought, well, this would be great to share with other people. So he shared these sets of exercises. And again, each of these sets has 8 problems, and they get progressively more difficult. This is actually the first one here, and you can see actually some of these are really quite easy. But everything builds on it, so you kind of need to go through everything step by step because things that you things that you program here, you're going to be using later on. So these exercises do not require you to have any advanced knowledge of abstract math, number theory, anything like that. So basically, you need to be a good programmer to do this. The other thing is, and related to this little bit on cryptography, is when I took it at the class at school. There really wasn't any discussion of attacks or weaknesses or anything like that. And I remember the professor saying that we could implement RSA, sort of, just the bare minimum as we knew it from the formula. And of course, if you try to do that, it's going to be a bloody mess. You're going to screw it all up. So that was another reason I was thinking about doing this. So the first thing that they talked about in their talk was CryptoCat. And it was kind of interesting. What they focused on in this first thing was that during this period of time, they kept actually weakening the cryptography. They were cutting the key size. One time they cut it in half, and they showed the different code. And the strange thing was that developers were actually kind of pleased with the efficiency improvements. So they were thinking about one thing, but they hadn't really thought through the security implications. The second problem they looked at was dealing with this and looking at RSA. And there's a variety of attacks. I listed one of the gentlemen that wrote a paper on it, Joe. I think it's Boneh, B-O-N-E-H, but he wrote a paper on 20 years of attacks on RSA. So there's a variety of padding attacks and different things that you can use against RSA. What they did in their attack, what they showed on the slides, was that they just showed that because of this 2 here, these 2 bytes we actually know, but since you have a 2 here, this can actually serve as a bounds to figure out the rest of RSA. So this is actually called an oracle padding attack, and the idea is that you're sending these messages to an oracle or a server, and what information you get back is whether or not the padding is correct. And that's basically all you need. That's the information that's being leaked, and from that you can actually over time put together the message. The other thing they talked about, which was kind of interesting, was, you're right, elliptical curve. So I'm not going to try to go into that, the math or anything there. I was actually on the internet just last night, and I came across this. These are the gentlemen that actually are the men who actually organize and work on these protocols and cryptography, etc. For OpenSSL. And the example they used for their talk was elliptical curve. And basically, they had two different curves. I think it actually involved, they didn't say this, but I think it involved point validation. So that one of the curves that they were using was actually a secure curve. Another curve was actually insecure. And so what they were trying to do was force the target onto the insecure curve and trying to force her to use that curve so that they could attack the Diffie-Hellman key exchange. And I thought it was really interesting. I read through some of the messages, and I don't actually know. Some of the mathematics I really wasn't too clear about, but I thought it was kind of interesting because they were talking about things that could allow an attacker to force a session key, etc., etc. It was interesting to me. So, anyways, if you have any interest in this, you can. This is the website right here, CryptoPals.com. And I think these are two articles I came across in terms of the passwords. But if you go here, you can get all the information on the exercises. And I forgot to mention this, but on GitHub, they also have solutions for the exercises, and I know that they're in Java and Python. Python was actually used 41% of the time. But so the exercises, if you want to look at solutions, they're out there as well on GitHub. So this is on passwords. So this is about how we try to create passwords that are in some ways easy to guess, but hard to remember. This one gives another example of this guy trying to remember, was that horse staple? What was it? So the point of the cartoon, and I forget who the cartoonist is, so I didn't attribute it to him, but that users create 20 years of this, and we've helped users create passwords that are difficult for them to remember and easy for computers to guess. So I had actually read some papers and some information from him. He did a PhD at Cambridge on guessing human chosen secrets, and he looks at entropy and information that each password has in terms of its complexity. So he writes in this light blue touch blog, and it's for Cambridge, and there's some other researchers there that do work in cryptography. And so basically, if you're going to do cracking, you need power, and that's CPU or GPU, and this has been increasing exponentially along, as predicted by Moore's law. The other thing is in terms of efficiency, and we're not doing a very good job of measuring this. There really aren't any benchmarks that are used. So password attacks, we're going to look at some offline issues here today, but really the more compelling more compelling stuff is really online in some ways. So these are some of the things that he wrote about Joe, about it's not really a major threat at the time for web passwords. And cracking efficiency, it's primarily for certain attack scenarios. So this is one of the contests that they run at DEF CON, and point of fact, or in point what he was mentioning about the metrics, they don't really measure these separately. They sort of measure everything together. Even the contestants, they don't have the same equipment, they don't have the same anything. So, and they don't really measure the efficiency, how many guesses were made, how many hashes were cracked, anything like this. Skip that. So here's one of the articles I ran into, and it's kind of like the hysterical article. These are these headlines that just puts fear into everybody's mind. And this one, oh, how they ransack, yeah. So, oh, yes. I actually didn't have the robot from Lost in Space, so I used Godzilla this time. So what the R's, they ran a contest with 3 hackers, and they were using MD5 hashes, but what they don't really talk about is that there wasn't any salt used on these hashes. And they don't really talk about the GPUs, the Radeon graphics cards they're using, and a lot of other things. So let's see. Oh, this was actually something I did in OpenSSL, but I was just doing this to show you sort of what a password can look like if you get it, or if you see it in storage. I'm not exactly sure it's stored this way, but this is actually a delimiter, and this just refers to the algorithm, the salt, and this is the hash here. So I'm sorry, I don't mean to confuse you here, because the Ars Technica, that article doesn't use any salt, but if you enter your salt in here and the password in here, then it'll come back. This is the same thing that was on the previous page. It'll come back with that. So these are the graphics cards. I think this is Amdahl, but these are right now around $500. One of the things that's really interesting to me about hash functions is that, well, these ones were designed to be very efficient. So fast is good, fast is better. And so normally in cryptography, we want to have something that's easy for the users to use, like private keys or public keys, calculating those with RSA. But we want to create a difficult problem for the attacker, which would be factoring these large prime numbers. The interesting thing is that more efficient we make this for a server to check or a computer to check a hash against the password, we also make it easier for attackers to also do the hashing and try to match those. These two last ones here, bcrypt, and there's also an script, but these were actually designed for hashing passwords, and they're called adaptive because there's a work factor in the bcrypt, and so you can actually slow it down to by the number of iterations it goes through. And so even if hardware tomorrow is better and better and better, you can actually change the work factor in there, and you can actually slow it down. So this was the first. Oh, here are the 3 people that did took a look at this. There were 16,000 passwords. And what was interesting is that they were all really good in the first hour or so. But the longer they kept at this, you really saw a lot of diminishing returns on these. They all use this OCL hashcat, and these two worked on this just for about an hour or so, and this guy really was pretty amazing. And I thought from an auditing point of view, from a security point of view, it would be interesting just to look at what they did real briefly. So I mentioned they use this OCL hashcat. So he did the brute forcing 1 to 6 characters. For length 7 and 8 characters, he was much more selective. And if you look at a brute force attack here, you can see it goes up here exponentially, or maybe more than that. Once you get to 6 or 7 here, you really reach an incline there. So after that, he went to hybrid attacks, Markov chains, and this is very interesting to me. They went to, a couple of them went to site-specific password hacking. So the passwords, a couple of them observed the passwords used on the same site are often very similar. And so they look at the hashes that have been attacked successfully. They look at the plain text password and try to derive information from that. So he did an amazing job here. It was really interesting. He does an iterative process. He creates a mask. Some of these look like regular expressions based on what he's seen, patterns that he's seen, and then he keeps rerunning and rerunning it again. And this was one of the interesting things that I found about these attacks was he concentrated on, or he talked about scraping the company's website to get information about them, their field of business, etc., and trying to use that as part of the passwords. He said that he uses masks, and sometimes these are called mangle rules, but these kind of remind me of regular expressions. So this radix, this is the second thing he did. He took these planes and he put them through a password analysis tool. And so some of these are actually pretty simple in that numbers are normally put at the end of words. So for some of them they did, you could do a brute force on the first 6 characters and then just add a variety, add every number, possible number for the three numbers after like 6 digits. So these were kind of based on what they saw and also what they have seen in general. Yeah, this is actually the latest one they have by this gentleman here, and he's written a paper about that. It's also on GitHub. So let's see, this is Bscript. Yeah, it's based on Blowfish. And actually, when you start Blowfish, it has to create a table, and it actually is really quite slow at the beginning of it. And basically, I had mentioned work factor earlier, but basically these are parameterized, so you can change the value of those parameters. And this I think I got from Java. You have log rounds, the work factor here, and this is the article by these 2 researchers for Bscript. And so, kind of ending here, the Ars Technica, this is just an unfortunate situation with computer security and network security. So users have to come up with better password hygiene. I think that they need to come up with better English, especially for users. Even if you use salt, you're not safe. Oh, so then they came up with one example for this. When you're attacking a celebrity site or something like that, you're just trying to crack a single hash. So I just think it's an unfortunate situation where people, the customers have a lot of fear, and they're not, even the ones that try to educate themselves find that very difficult to do. They went on to say that they were going to publish a article on password managers, which I haven't looked at, but this article came out in 2014 from some folks at University of California at Berkeley, and they had looked at 4 out of 5 password managers on. These were web-based, but they were all problems with them, and they all had a million users or more, and they were heralded by PC Magazine and CNET, et cetera, et cetera, et cetera. So let's just say this is kind of an unfortunate situation at the moment. I also really enjoyed this. This is a presentation they gave back at the end of 2012. It's on hashes, and it goes through the whole history. And there's some really interesting things in there about bit slicing and how do you take DES or a symmetric cryptography and create a hash out of it, because initially there were no hash functions back when they needed them. So it's a very interesting article. So thanks for joining me, and I will talk to you next week.